Hey, good morning, everyone. My name is Majdi. I'm very thrilled to be with you today and to defend the topic of my presentation entitled Modern Technological Advances for Sustainable Concrete Technology, a Critical Review. This work is prepared by myself, Majdi, and supervised by Professor Mansuf Nadi. It is submitted as part of the requirements of the course of Civil Engineering 704 C03, Advanced Concrete Technology for Net Zero and Sustainable Construction. Just before we start and dig into the presentation, I just want to give you a brief story of what happened exactly and a little bit of my background. So I'm originally coming from Gabes, Tunisia. It is a city considered as one of the most polluted cities in the world. We have a lot of carbon dioxide emissions coming from different, more than 10 factories built back in 1970s, 1980s. And since that time, the environment is having a lot of issues, whether people, vegetations, animals, trees, all kind of like different living habitats are finding a lot of troubles, and the city of Gabes basically it's downgrading the quality of living, and especially when it comes to the air quality, things are going so down. So I grew up into that atmosphere, and I wanted one day to become a scientist or an engineer that can investigate all these problems. And one day, who knows, maybe valorize all these problems and wastes and make basically my city a better place to live for future generations. And that's what we are talking about. We are talking about sustainability. So today I have the option. Today I'm fortunate enough to be one of the people of the city that went outside and tried to basically find innovative solutions on how we can make the city a better place to live, and also how we can make the people basically in the city satisfied with the quality of living. So as you can know, I mean, like the problem of CO2 emissions is a big problem nowadays, and especially after the Paris Agreement back in 2015, the United Nations has set a goal not to go far beyond 1.5 degrees Celsius into the temperature. So this research is a part, and it's under that obligation, and we are all obliged as scientists, engineers, lab experts, everyone, to develop a better way on how we can make our world a better place to live. So we're gonna start by an introduction, and then we're gonna talk about the current practice that the material scientists or engineers are doing nowadays. Then we're gonna talk about the technological advances being applied in other fields and other sectors. For example, talking about transportation, talking about the energy field, talking about the health field. So a lot of different other sectors. And then we're gonna try to present our motivation, why we are doing this work, and basically conclude with a list of findings that we came up at this critical review. Then talk a little bit about limitations, and of course presenting some ideas and ways to open the door for further research. So as we were talking about, carbon dioxide emissions is a big issue nowadays. And if you can see, everybody is talking in the news about the carbon dioxide emissions and how we can make it less. Everybody is talking about the zero concrete emissions. Everybody is trying to discover a new way on how we can make and how we can advance the building sector. So as you can see into that pie chart from the top left, we can see that about 11% of carbon emissions are coming from the sector of building materials and construction, where 10% are especially coming from the clinker production, which is the main particle, the main glue of the cement particles. So, I mean, there is the current practice right now is basically just to use, cement with the, with the very standard and traditional way of using coarse aggregates, fine aggregates, cement, water, air admixtures. However, it was, demonstrated that this way is very old, and it has a lot of drawbacks on the carbon emissions. Unlimited number of mixes being produced every day in the world by India, China, Brazil, United States, and also the idea is the production of cement is gonna always go exponentially because it is one of the most easy materials to work with, and it is very available in almost every country of the world. So some scientists try to incorporate different supplementary, that what we call the supplementary cementitious materials, whether ash, silica, slag, sludge, and different kinds of materials. And as you can see, all the materials look the same. If you don't have an advanced tool and an advanced laboratory testing, you cannot really determine which one is the one that you want to use into your mix. And also, right now, a lot of research teams, and one of them is at Delft University, is trying to incorporate recycled aggregates. And the recycled aggregates from the construction and demolition waste. How we can determine the right proportions? That's the question that we should ask. How we can determine that we need, for example, 30% of silica fume, 20% of fly ash, and 10% of the recycled aggregates? Nobody can know. Usually, in the cement and concrete plants, what's the current use is basically just to use something based on their experiment, based on their experience. They will say, okay, we used this back in 5 years ago, and it was always amazing, and it was always the same, performing the best with less money. That's what contractors and producers care about usually. However, this process is very energy intensive. It takes a lot of time, a lot of efforts, and also it needs expertise. You need somebody who has enough experience to go and try to, for example, let's say that one day, for a specific reason, for example, the humidity of the particles, of the recycled particles, or the degree of fineness of the supplementary cementitious materials is not as typical as what happened before. So usually people, what they will do, they will add more superplasticizers or viscosity modifying admixtures to bring the concrete to be in a workable state. However, we don't think that this is the right way. Other 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 sectors, including the transportation sector, including the health sector and the energy sector, they try to incorporate different technologies into their practice. And the problem is, in civil engineering, we are always behind in that, and usually people or the stakeholders or the people driven with the business-oriented ideas, they don't usually go for those technological advances. Just they care about money and time of delivery. However, they should think about the importance of using, for example, the technology of 3D concrete printing for accelerated construction, and also the technology of artificial intelligence, which is almost being applied everywhere right now. So that's the idea of this research. We are basically trying to summarize all the different research work conducted in the last 5 years, starting from 2018 up to 2023. We are trying to delve into the different ideas and how each research team is trying to develop a better concrete mixture, how we can optimize these additions that we were talking about, like how we can determine the right proportions, and also, is there any way that we can determine and understand some correlations between these additions? That's what we're gonna discover into this presentation. So again, this presentation has about 80 references where it is divided into two different sections. The section number one is basically for the 3D concrete printing, and the section number two is for the uses of AI. 40 references for each section, all talking about the different uses and the different ideas that we can incorporate into the future. So we came up with a list with after discussing, I mean, like into, if you can go to the paper, we basically discovered that based on a list of tables, figures, we try to discuss and analyze the different ideas that we have into our presentation, the different ideas we have into our paper, and we came up with a list of findings. So for 3D concrete printing, for example, we discovered that the recycled concrete aggregates can improve printability and interlayer bond strength. The standard practice was just using cement and fine particles with a little bit of admixtures and water. However, again, we are trying to reduce as much as we can the quantities of cement into our mixture. So here, as you can see, the recycled concrete aggregates can improve the printability and interlayer. The recycled glass particles can reduce the alkali-silica reaction. The recycled brick aggregates can achieve good printability up to 64% replacement. You can imagine 64% reduction of cement. What amount of carbon dioxide emissions you are reducing by adopting this technique. Then the plastic aggregates, up to 10% replacement. They can work for most structural elements and also geopolymers. What we mean by geopolymer is basically a mix that has different supplementary cementitious materials with no cement, basically. Can enhance mechanical properties and printability. So that's what we are looking for. Then for machine learning applications, we discovered that like a list of algorithms and architectures are being used. However, the XGBoost model provided the best predictions for properties like compressive strength, flexural strength, carbonation depth, creep coefficient, and chloride resistance, superseding basically the existing mathematical and machine learning models. So this model, for example, discovered existing correlations between different parameters, including the water binder ratio, supplementary cementitious materials, percentages, curing age. All these parameters significantly influenced the concrete performance. So this study presented a list of limitations, and we are trying to summarize them into this slide. So for 3D concrete printing, we discovered that adding this kind of recycled particles can increase the water demand, which can lead to some shrinkage issues, and this also can lead to reduced long-term strength and a decreased to some extent into the rheological properties and the viscosity of the mix. For machine learning applications, again, we cannot fully automate the sector. They can help, into determining the predictions of the models, but always the assistance of an expert tester and or quality control manager is always requested to maintain the validity of the results. So we are trying also to incorporate more data, basically from a real life scale, because as you know, the real life construction sector has always some noisy data, some outliers basically. So we are always trying to diminish that number and basically build a stronger and a more reliable data set so we can build robust models. Also, from a machine learning perspective, we noticed that there is no real-time data. So all the data being used is basically based on lab testing, experiment testing. So the method of machine learning algorithm we're using is supervised training. So we want to have unsupervised learning, so we can basically maintain 100% fully automated inspection and optimization algorithm. So the construction industry will become 100% responsible by itself for its results and for its quality of deliverables. Then opportunities. Talking about the opportunities for the different sections that we incorporated into our study for 3D concrete printing, we are basically, as a research community, trying to think of improving the machinery and the nozzles, for example, used. What's the purpose of using green materials? And a green mixture having incorporations of supplementary cementitious materials and recycled concrete aggregates, while at the same time the main system printing the structure is being fueled by fossil fuels. So we should think of renewable energies and I mean more efficiency into the printing stage. We discovered that there is a lack of studies tackling life cycle analysis of 3D concrete printing structures. We can, I mean, like understand that because the technology is still at its early adoption. So maybe in the future, more research studies are going to focus on life cycle analysis of 3D printing concrete structures. And also we can incorporate some carbon capture use and storage techniques into the 3D printing structure. So we are trying to kill basically the CO2 emissions into any kind of 3D printed structure. Then for machine learning applications, we should think of a unified data set so everybody can use it, and metrics. So I mean the studies can, when we compare the studies in the future, we can have a reference, for example, to say, yes, we performed better in terms of accuracy, in terms of R-score, in terms of MSE. So all these performance metrics of machine learning, they should be unified so the comparison could make sense in the future. And also, we should think about lowering the computing time of the machine learning algorithms. We don't want to take 1 hour to get the result. It has to be very quick in a matter of seconds so the user can trust this kind of machine learning algorithms. This is the list of references. Well, this is the end of the presentation. I hope you guys enjoyed what we talked about today, and I hope it nails your attention in the future. If you have any more questions, please feel free to contact me, whether for using my email address or using my phone number. You are all you are always welcome, guys, and thank you so much for this, and have a lovely day. Thank you.